Did you know that companies like Google, Amazon, and Microsoft frequently use this exact problem to test your ability to handle pointers and in-place array manipulation? Welcome to the ultimate walkthrough for LeetCode 26, the Remove Duplicates from Sorted Array Challenge. Let us look at the problem statement. Imagine you have an integer array, nums, that is already sorted in non-decreasing order. Your mission is to remove the duplicates in place, so that each unique element appears only once. The relative order of the elements must stay the same. Then, you need to return the number of unique elements, which we call k. Think of this like cleaning up a stack of sorted documents where some are repeated. You cannot just grab a new stack, you have to clean the existing one without using extra space. The rules are strict. You must modify the input array in place with O of 1 extra memory. This means you cannot create a new array or use a hash set to store unique values. You have to rearrange the elements within the given array itself. To wrap your head around this, think of the unique guest list analogy. Imagine a line of guests waiting to enter a premium club. We have 3 roles. The scanner, who checks every guest in line one by one. The gatekeeper, who only lets a new unique guest enter. And the placement, who ensures that these unique guests are seated at the very front of the club, one after the other. If the next guest is identical to the one we just seated, the gatekeeper denies them entry and the scanner moves on. Our strategy follows a golden rule, the 2-pointer approach. We use a slow pointer, I, to track the position of the last unique element we have found and placed correctly. We also use a fast pointer, j, which scans through the entire array to discover new values. If the value at j is different from the value at I, it means we found a new unique guest. We move our slow pointer I forward and copy the value from j into that spot. This is a brilliant way to handle things in one single pass. Now, let us dive into the dry run. This is where the magic happens. Look at our array on the screen. We have 0s, 1s, 2s, 3s, and 4s, all sorted but with many repeats. Notice the variable tracker box below, it tracks our pointers I and j. We start with I at index 0 and j at index 1. At index 0, we have a 0. We compare it with index 1, which is also a 0. They are the same. So, we skip this duplicate and move j to index 2. Now, j is at index 2, and the value is 1. We compare it with our last unique element at index I, which is still 0. 1 is not equal to 0. This is a new unique element. We increment I to index 1 and copy the value 1 from j to I. Now, the first 2 elements of our array are 0 and 1. Moving on, j scans indices 3 and 4. Both have the value 1. Since our last unique element at index I is also a 1, these are duplicates. We skip them and move j all the way to index 5. At index 5, we find a 2. Comparing this with our last unique element at index I, which is 1, they are different. We found another unique value. We increment I to index 2 and copy the value 2 into that spot. Our array front now looks like 0, 1, 2. The process continues. J scans index 6, finds another 2, skip. J moves to index 7, finds a 3. That is new. Increment I to index 3 and copy the 3 there. Finally, J moves to index 9, finds a 4. This is our last unique element. We increment I to index 4 and copy the 4. Dry run complete. The unique elements are 0, 1, 2, 3, and 4, all packed at the front of the array. The final count k is I plus 1, which equals 5. Now that we have walked through the logic visually, let us see how these pointers translate into our Python code. We start by checking if the array is empty. If it is, we return 0. Then, we initialize our slow pointer I at index 0. We start a loop for our fast pointer j, ranging from index 1 to the end of the array. Inside the loop, we check the condition, if nums j is not equal to nums I. If this is true, we found a unique element. We increment I and set nums I equal to nums j. Finally, we return I plus 1, which represents the total number of unique elements found. Looking at the complexity, this solution is incredibly efficient. The time complexity is O of n, because we scan the array exactly once with our fast pointer. The space complexity is O of 1, because we modified the array in place and only used 2 integer pointers, regardless of how large the input array was. This is the optimal approach for this classic interview problem. And that is the Remove Duplicates challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner to help them level up.